Hi everybody, today we're going to talk about reciprocal trig functions. That means secant, cosecant, and cotangent. We'll start by going back to the sine of t being equal to the opposite over the hypotenuse. If we spin that around and form the hypotenuse over the opposite, we'll call this new ratio the cosecant. Our abbreviation for cosecant is CSC, and again we'll put in our reference angle of t. I want you to think of cosecant of t as the reciprocal of sine t, so cosecant of t will be equal to 1 over sine t. We have two more reciprocal functions to talk about. Secant of t, abbreviated as SEC of t, is equal to the hypotenuse over the adjacent, but I think you'll find it easier to think of secant t as the reciprocal of cosine of t. This says secant of t is 1 over cosine of t. Lastly, cotangent of t, abbreviated COT of t, again, we want to think about this as the reciprocal of tangent. That means cotangent of t is 1 over the tangent of t. Let's practice finding the 6 trig functions for the triangle 48, 55, 73 with an angle of alpha. We'll start with the sine of alpha. Opposite is 48, the hypotenuse is 73. Cosine of alpha will be 55 over 73. Tangent is opposite 48 over adjacent 55. To find secant, I'm going to use the reciprocal of cosine. Since cosine was 55 over 73, secant will be 73 over 55. Cosecant is the reciprocal of sine. Sine alpha was 48 over 73. That makes cosecant of alpha 73 over 48. Cotangent of alpha is the reciprocal of tangent. Tangent of alpha was 48 over 55. When I flip that over, I get 55 over 48. Next, we'll find the 6 trig values when t is 4 pi over 3. We want to start by finding our angle. 4 pi over 3 is in the third quadrant. From our standard angle, we can find our reference angle by including a vertical line to the x-axis. This tells us that our reference angle is pi over 3. Because we're in the third quadrant, both the sine and the cosine will be negative. Sine will be negative square root of 3 over 2. Cosine will be negative 1/2. The sine of t will be negative square root of 3 over 2. Cosine of t we said was negative 1/2. Tangent is sine, negative square root of 3 over 2, divided by cosine, which is negative 1/2. Negative the square root of 3 over 2 times negative 2 over 1 says we have a positive square root of 3. Remember we said that the signs of the quadrants were all sine, tangent, and cosine, so we expect tangent to be positive in the third quadrant. Secant will be the reciprocal of cosine, so if I flip negative 1/2, I get negative 2 over 1, which we can write as negative 2. Cosecant will be the reciprocal of sine, so I have 2 over negative square root of 3. We won't keep the radical in the denominator, so I'm going to multiply by the square root of 3 over the square root of 3. This gives me 2 square root of 3 over negative 3. I'm going to write that as negative 2 square root of 3 over 3. Cotangent of t is the reciprocal of tangent. Tangent is the square root of 3. Cotangent will be 1 over the square root of 3. Again, I multiply by the square root of 3 over the square root of 3, giving me the square root of 3 over 3. When you look back to even functions, hopefully you remember that f of negative x would be equal to f of x. This says when the point xy is on the graph of f, then the point negative xy will also be on the graph of f. If you look at cosine of pi over 6 and you look at cosine of negative pi over 6, they're both equal to the square root of 3 over 2. Both the positive and negative angle have equal values. Continuing around the unit circle, you'll see that cosine of pi over 4 and cosine of negative pi over 4 are both equal to the square root of 2 over 2. You can also see cosine of pi over 3 is 1/2, and cosine of negative pi over 3 is also equal to 1/2. In each case, the cosine of negative x is equal to the cosine of x, which tells us that cosine is an even function. If we were to take a look at sine, we won't see the same thing. Sine of pi over 6 is 1/2. Sine of negative pi over 6 is negative 1/2. This shows us that the sine of negative pi over 6 is equal to negative the sine of pi over 6. You'll also see that the sine of pi over 4 and the sine of negative pi over 4 have opposite signs. This says the sine of negative pi over 4 is equal to negative the sine pi over 4. This continues with pi over 3. The sine of pi over 3 is square root of 3 over 2, but the sine of negative pi over 3 is negative the square root of 3 over 2. In each case, our sine of negative x is equal to negative the sine of x. We call this type of function an odd function. By definition, when f of negative x is equal to negative f of x, we say that f is an odd function. This tells us that when the point xy is on the graph, then the point negative x, negative y will also be on the graph. This breaks our trig functions into two types. Cosine and secant are both even functions. Cosine of negative t will be the same as cosine of t. Secant of negative t will also be the same as secant of t. Sine, tangent, cosecant, and cotangent are all odd trig functions. The sine of negative t is equal to negative the sine of t. Tangent of negative t is negative tangent of t. Cosecant of negative t is negative cosecant of t. And cotangent of negative t is negative cotangent of t. Let's try using this knowledge to simplify a few expressions. If we're given that the cosine of theta is 1/5, we want to find cosine of negative theta. Because we know that cosine is even, we know that the cosine of negative x is equal to the cosine of x. This says the cosine of negative theta will be the same thing as cosine of theta, which tells us cosine of negative theta is 1/5. Secant of theta is the reciprocal of cosine. Given that cosine is 1/5, secant will be 1 over 1/5, which is equal to 5. Next, we have that sine of theta is 3/4. We want to find sine of negative theta. We know the sine of negative x is equal to negative the sine of x. That says the sine of negative theta will be equal to negative the sine of theta, which tells us we have negative 3/4. Cosecant of theta will be the reciprocal of sine. We'll have 1 over 3/4, which gives us 4/3. Even and odd functions are called symmetry. Symmetry will be very important as we move into graphing in the next video.